Hey guys, today I am going to cover how I did a hack on a contract that rareskills.io sent out yesterday. I'll just walk you through how I did it. I'll teach you the elements behind it, basically what was happening as the hack was taking place, and then I'll also give you some hints as to how you can start hacking on your own and become really good at understanding the mechanics behind smart contracts. So before we get started, feel free to subscribe and like this video if you'd like to see more content like this, and definitely leave your comment. What did you like? What did you not like? All right, so let's dive in. So basically, I want to start at the hack. Okay, so yesterday, Rare Skills on LinkedIn, at least that's where I saw it on LinkedIn, they sent out this hack, essentially. They took a picture of a smart contract like this and basically said, hey, if you can, we deployed it to the Polygon network. If you can go and steal the one Matic that's in there, then, you've hacked it and it's yours. At least they haven't asked for it back. So, all right. So what I was actually on my way to bed, but I was like, all right, let me do that. Okay, let's just go through the contract first. It's called Steal. It's written in Solidity 0817. So we kind of know some things already just by reading that, is that there are some default safe like guardrails in place, basically, right, around like safe math and stuff like that. That won't be necessary here, but it's just like in general, the version number can immediately point you to some known vulnerabilities. So it is important you always keep your code as up to date as you can and as makes sense for your application. Okay, so let's look at it. So there's a contract called Steal. It has one storage variable. It's an address. It's a private variable. Remember that just because you put private here, it does not mean that others can't see it. That fact is not relevant to this hack, but it's just important that you know. So when you see private, it's not like you're hiding stuff. Nothing is hidden on the blockchain. Unless you encode it actively yourself, but that's certainly not something Solidity does. Anyway, just wanted to point that out. But there's an address, and it's the owner. That owner gets set when you construct this address. So presumably, someone constructed on their side. They sent one. Okay, I'll get to this in a second. Okay, it's a little bit complicated. It wasn't in Ether, okay, but we're in Polygon. I'll explain what that means. But they sent one Matic when they constructed it, and this contract would then set the owner to whoever constructed it. Okay, this Ether is just a keyword for 10 to the 18. Okay, so it's not that they sent an Ether, they sent one Matic, but it's just whatever unit you're on that chain, it's just 10 to the 18, which is typically one token, so for example, one Matic. Let me know if you want that explained in more detail, but we're going to move on. So this constructor code is only run once, okay, when the contract is created. And this is not like this function will hang around in the contract after, and you can somehow hack it or call it or anything like that. No, it's called once during what's called the init code. So someone being like the node that received this contract creation code, did the construction via the init code. And the init code, aka the constructor, deployed the runtime code. Okay, the runtime code is everything else than the constructor. Okay, and that's what actually got deployed. All right. In any case, in any event, this owner is set during construction. Fine. Okay. And now we have two other functions. These two other functions will be part of the runtime code. So these are functions you can call when you call a contract. One of them is called Steal, and it takes in an address delegate. And it takes in another argument, a bytes memory. So this is like a bytes array called args. Okay. And the first thing it does, and by the way, another thing is that it's external in scope. So you can call it from outside, from an external source. And the first thing it does is, and this is always should be alarming to you, it takes any address that anyone inserts here. Anyone can call this function with any address. Should be immediate cause of concern. And against that address, they call this function called delegate call. Okay. And the delegate call is more like an internal thing here. It's not like they're calling that function. They are calling a delegate call, I should say. But they're using this arbitrary argument. That's another cause for concern. It's like you can just put whatever address, you're doing a delegate call, and you can put whatever argument you want here. Okay, that's a little bit too much freedom and trust in whoever calls this function. So you got to be very careful. There are some guardrails in check, as you can see. They check that, okay, was this actually was this actually a successful call? Yes, they make sure it is. And then that's important because then at the end here, they're requiring that nobody steals Ether, or rather Matic, from this contract, which again starts out with one Matic on construction. Okay, so that's what they do. All right, so far so good. Then they also have a withdrawal. Fine, they just make sure the message sender is the owner, and if it is the owner, well, they're going to transfer everything that sits in this account, all the Matic, to whoever calls withdrawal. So the first hack you could think of could be, can we call withdraw directly? It is external, there's no modifier, so maybe. But then actually the first line 18 here, is checking that message sender is the owner. So no, you cannot just call withdrawal. That would have been easy. That's not what it is. All right, moving on. So anyway, so we need to figure out a way to do this. So one thing you should think about when you're a hacker is this delegate call is something that's very dangerous in general. And I got some diagrams, so I'll explain you why. But just assume for now that the way we're going to do this is to deploy another contract called hack, and we, meaning like the human, like whoever deploys that hack contract, is going to deploy it, and it's going to call this attack function in the hack contract. And that attack function calls this steal contract. And we can put the address of the hack contract, and I'll show you everything in a minute, but we can actually make this call back into the hack contract because we can put whatever address we want here. So we can just put the address of the hack contract, and this code is going to run like our contract again, the hack contract. And in there, we can do some interesting things, and I'll explain how. All right, first of all, I just want to show you how this steal contract is kind of laid out in terms of storage, because that will become important. So this steal contract to the left, I'll plot it kind of like the runtime version to the right, and this is the storage layout. In Solidity, the storage layout is kind of like a dictionary. It has keys, like key 0, key 1, key 2, and those are consecutively ordered all the way to 2 to the 256. Technically 2 to the 255 is the last element. But it has 2 to the 256 elements, and they just go consecutively. And then the value is on the right here. So that's how it's represented. It's not like memory. Memory is different. Memory is more like an array like this that just goes like this, location 0, 1, 2, and so on. Okay? So it is different, and it is unique. The reason it has 2 to the 255 elements, which by the way, or 2 to the 256, which by the way is an astronomically large number. I mean, it's like number of atoms in the universe kind of number, is not the anticipation that people will need that much storage. That's not why they're doing it. Because first of all, it costs a lot of money to store in storage and read from storage. So that's not like the developers were not like, oh, we need to make this much room because we believe that will be used. It's actually more subtle, and another video I can create, which is like more related to how do you easily and very easily store like dynamic arrays, like dynamic types that can expand in size. Okay, so what do I mean? Like, just quickly on this, I know it's a little bit of a tangent, but let's say you were to store some, and remember, every time you store and even read from this, it's extremely expensive. So if I put 1, 2, and now I need to store an array that's dynamic, it can change in size. I don't know how many elements, 2 elements, 100 elements, 1,000 elements. Someone can just, I don't know. Where am I going to store it? I can store it here. I can start here with element, let's say it's 100 right now in size. So typically what Solidity does is stores the size in the first slot. And then let's say, someone stored 4 and 1 and so on. What happens if I clash into variables later on? Or what happens if I want to put some other variables in storage up here? Or if I have another dynamic type, let's say the first one here is a dynamic type, things like that. It's all going to clash together. And the workaround could be, it doesn't need to clash as long as you just move the dynamic array to a later spot but that's just extremely expensive. So you can't like start to like move things around as you clash into each other. It's just going to be too expensive. So their solution is to store dynamic things. They just hash the slot key. Okay, they just hash the slot key, and you know, basically with the value, it like depends a little bit on what dynamic type we're talking about. But the point is, they're just going to hash this. So they're going to say, oh, instead of storing it in like slot 2 onward, they'll just say, oh, we'll just store a new pointer, okay, here, and that pointer will be the hash of slot 2. Okay, so they'll do something like this. This is just a very like approximate way. It's not exactly what they do, but I'm gonna hash 2. That's slot 2. This output is gonna be some number. This is a hex, but it is a number. I can convert this to decimal. This is the slot that they're gonna store that dynamic array in. So maybe it's 1 billion. Okay, maybe it's a lot more, but maybe it's 1 billion. So that in slot billion. Okay, imagine that. Now you have 4. Go all the way down to 1 billion and start your array. And you can always get there in over one time because you could just hash this and always get to the start of it. But the point is they're creating such a big space where it can land in that the probability of clashing is super tiny. Okay, this is going to be a whole... I'm starting down a huge tangent. I'm just explaining you why the storage is so huge in terms of like what it can actually hold. All right. Okay, back on track now. So, okay, what we're just going to focus on here is that during construction, someone put the owner variable right here. Okay, so during construction, this owner was set to message.sender. The way Solidity lays this out in storage is that, well, first of all, you can see the amount of storage variables. You have one, it's just called owner. You just know that. All these other variables you're seeing are scoped to the function. They're not stored in storage. I mean, unless you explicitly ask to. But right up here is one variable, and it sits right here in slot 0. It starts to count from 0. Okay? That's it. There's nothing in the other slots, and nothing is tracked on the blockchain in terms of those slots. It just tracks this owner slot. So this is how the storage looks behind the scenes, and these are the functions. Okay. All right. So this is now it's time to introduce the hacking contract. We're gonna move this over there. There you go. It's like a cooking show. I already had this ready. And this is the hacking contract, and you see in the top right the actual full implementation of it. But really, we just need 2 functions. We need attack and we need pwn. Okay? And so this is how it's going to work. So we deploy this hack contract. When we deploy it, there's going to be some internal owner variable here. Okay? During construction, the owner is going to be sent to whoever created it. All right? It's important. Okay. All right. So I don't want to get ahead. Okay. So now this deployed, it has attack and pwn. So let's see what happens when we actually call this hack contract. The idea is we're going to leverage the attack on delegate call. I'm going to color this. We're going to attack delegate call. And we're going to make delegate call back into the hack contract. And we're going to make it call a specific function that we can force it to call. And here's how. When we call attack, there will be I forgot that. There will be we're going to just point it to the deployed steel. So when we deploy the steel contract on Polygon, it'll have some address, right? 12121 blah, 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 blah. It'll have some address here. Okay. We're going to put this address, when we call this, right here. We're going to input that address right there. And as you notice up here in the code, oh yeah, it's right here, right? Attack in line 17. And if you look at it up here in 3, I also have this steel contract that I implement, so I know the interface. That's just to say that I know this steel type here, and it also knows that, or it also means that I can use this simple syntax and just say st.steel directly here. Okay, anyway, so that's what happened. That's the address that goes in here. So this is something I put in when I deploy hack and I just call it. Okay, cool. When that address has been called out, as you can see, we call st.steel, and we're going to call it with address of this. Okay, so delegate over here is going to be, can we do that arrow again? That's a pretty cool arrow. Yeah, this address, except it's just the other way, goes right here as delegate, and it means it goes right here. But that's address that's the address of the hack contract. Okay, So what this means is that now Steal is going to say, okay, great. I'm going to do a delegate call against a hack contract. Okay, fine. So that's a good start because we kind of get it to do that. And then also for the arguments, okay, what we're going to put is a way for so right here, we're going to put the function signature of pwn. Okay, we're going to put that as the arguments. So that means when this does a delegate call, okay, mechanically what happens is the delegate call calls this entire contract here. Okay, this just calls back into hack like that. And I'm just showing it hit the boundary of the contract because it just means it doesn't call a specific function initially. It just calls whatever that args data is, it just calls back into hack.sol with that args data, which is just a bunch of hex characters we can think of. Okay, like this. Let's just say we send in this. Like that, okay? So it calls it with this. All right. What happens behind the scenes in the hack contract when it gets called with some call data like that is that it's going to try to figure out, it's going to try to dissect this data, and it's going to take the first 4 bytes, 1, 2, 3, 4. It's going to take these first 4 bytes, and it's going to try to do a selector on those 4 bytes, by which I mean it's kind of like a dispatcher, rather. It's going to basically try to figure out, okay, these are the 4 bytes. Presumably, they should point to a function signature, okay? So presumably, these correspond to, like, attack, okay, or the pwn. So what do I mean by that? Let's say we wanted to call pwn. How can we do that? We can go here, and we can put the function signature right here, and you can see the first 4 bytes. 1, 2, 3, 4, okay? And you can put that right here. If you did that, 1, 2, 3, 4, okay? If you did that like that, it would take this. This happens to be the signature of the pwn function. We just did that in the Ketchek 256 calculator. It's going to go through the contract behind the scenes, and the dispatcher is going to just test one function at a time in a linear fashion, at least if you have small enough few functions. If you have a lot of functions, it's going to do binary search. It doesn't matter. It's going to go linearly, just think about it like that. And then it's going to just ask each function. It's just going to ask, hey, attack, do you have this signature? This signature right here? And attack is going to say, no, that's not my signature. Okay, then it's going to go to the next one. That's pwn. Hey, pwn, do you have this signature? Yes, it does. I mean, we just confirmed that. Yes, it does. Great. Cool. It's going to take the rest of this stuff and just send in as call data if necessary, or just strip it away if not needed, right? So that's it. Okay, cool. So in this case, what we can do is call, like, a quick way to do what I just did here with Ketchek Online and all this stuff is that Solidity offers you this API, global, like, library here, and you can call encode with signature pwn. So you can actually, this just does that. It does that 0x and puts the signature and zeros for the rest and all this stuff. So great. That was a long way to just say when this call comes back in, the delegate call comes back in and calls the hack contract generally, we have ensured that the data that comes in is such that the dispatcher behind the scenes picks and calls the pwn function. So we're going to land right here when we call back in. Okay? So what has happened so far? We deployed the hack contract. We being like me or you, the hacker, calls this attack function. It calls the steal contract. So, okay, I'm going to follow it along. We deployed it here. This is where I am. We called this function, attack. This called this function over here, steal. And specifically, well, they called that contract and this function right here, steal. Okay? Now, steal is going to delegate call back over here into pwn because we told it to. Okay, cool. So now we're calling this function. Okay, here's where it gets crazy. Okay, this up here, let's be more specific. When we deploy the hack contract, which owner is this? This is 0x hack deployer. We're going to start to distinguish. This owner over here in the steal contract was 0x, I'm just putting some random addresses to distinguish them, 0x steal deployer. Okay, so whoever deployed that is over here, and we are over here. Okay? Now here's where it gets crazy. When you call delegate call, it will run the other contract, so it will run hack.sol, That's what I mean by the other contract, is whoever it calls the delegate call against, which now is the hack contract because we told it to, it will call that contract against its own context. Yeah, that's a little wild. So what I mean by that is, what do I mean? I mean that it's like we're running this over here against this. I wanted to make that yellow. Maybe we can do that. Yeah, this is a little crazy. It's as if it just kind of throws away the... I mean, I can draw it in two ways, but like I just kind of want to... Like it just kind of like plops this right over like that. Okay. And it... can we just set the opacity like that? Yeah, we can. Okay, that's going to be crazy. So what we can do is move this to the back, and we can just set the opacity. All right, cool. And then we can move this. We can maybe group it together. Can we group all of this together? Okay, I'm not super. Oh, I can lock it maybe, and then I can move it to the front maybe, and then we can move. Oh, it locks it in place. All right. Well, okay, cool. All right. Sorry about that. Okay, cool. It kind of, there you go. So it's okay. So back on track here. So delegate call, it calls hack.sol with the context of who called it. So with the context of steal. What do you mean by context? I mean the storage, actually. The storage variable, message.sender. So okay. Yeah, no, that's a separate thing I want to talk about too in a following video. Message.sender, message.value, as they came in when we called steal, are gonna be like that in Pwn as well. But most importantly, the storage variables as well. So it's as if this contract over here is just suddenly starting to operate on steal.sol storage space. Crazy, right? That's what delegate call does. That's why you have to be so careful. So let's see what happens. Well, now we have access to steal.sol storage space. What? So this means whatever we put in this body here, well, we're just going to put something that changes that storage space. I'm gonna tell you a little bit of a detail in a second, but for now this is what it is. So the point is that we can actually just swap these two and put whatever we want up here. Again, in steal.sol storage space. So now I can put 0x hacker. And of course, this is just a visual thing. So when I say I change it over here, like it also changes over here. These are the exact same thing. Another way I can visualize this is having this arrow go all the way over there, because this is actually the one we're manipulating. Okay, that's another way to think about it. Like forget about this thing I drew in the middle. Like I'm going to put myself here. Forget about that thing. We're actually pointing back into this as another thing to think about it. Is another way to think about it. But I'm just redrawing it here on top of, just so you understand that like it's kind of as if we just replaced that storage space with steal.sol storage space. Okay, that's what's happening. That's crazy. So now we're going to set it to tx.origin. Tx.origin is the hacker, the EOA, the human account. So that's going to be the hacker. And that's it. So over here in this deployed contract, by the way, it's now just swapped. It just changed to 0x hacker. Done. Okay. When that Pwn function is done running, and we're going to move this as well. Okay. We're going to just delete that. And we were somehow coupled to the background there. That's wild. Okay. All right, you get it. The old storage space is still over here. I'm having some trouble today with this. All good. So here, all right, so this is back at this. And this, by the way, is still the old value here. What was that? Hack deployer? We haven't changed this stuff. Okay. So we changed this stuff over here because when the delegate called, we started acting on this. Okay, fine, we get that. So what's happening? Well, that ended. Now we're the owner over here. We've successfully changed the owner. And now all there is for us to do is just call withdraw. Because message.sender, I mean, we'll just call it from the human account. We'll just directly call withdraw. We don't need to call that through the hack. And then the message.sender, which will be us, will be the owner. Because that was the tx.origin we said originally. And that's it. It'll send us directly to our human account, not to this address. This address is done. It'll just send to us directly the funds. And we're done. We hacked it. So that's what's happening. The detail I wanted to talk about was that, wow. Okay. I need this. Okay. The detail I wanted to talk about was that, oh man, I should probably show, I'm going to stop recording there. It's sitting right on top of, it won't go away. No worries. So basically, can I add text? So basically we have this like address, private, owner, okay? Like this is also shown in the contract over here to the right, but let me just reproduce it here. This was important. We put this over here when we deployed the hack. It wouldn't have worked if we hadn't put that there. We had to define this variable because that would occupy this storage slot up here with something. And that allowed us to then access it over in steal.sol. It's a little bit strange, but that's what it is. Also, it doesn't have to be called the same. This can be called coffee is good. Okay, coffee is good. And then coffee is good, can be said during the construction. Here, coffee is good equals message to sender. Doesn't matter what it's called over here. So it's not that, I want you to understand, it's not that it's linking based on the name of the variable. It's not that it's saying, oh, you want to delegate call into hack. Oh, look, hack also has an owner variable. Okay, let me pretend like that's this owner variable. That's not what I'm saying. It is the fact that just whatever, it's the fact that owner over here sat in slot 0. That's what matters. So whatever sits over here in slot 0 is the one we need to change. So what I mean by that is we could have had something coffee is good and owner, 2 variables. Owner would have sat in slot 1. This would have been the owner. Now to hack it, if we did this again, notice we do have a variable called owner now. We have one called coffee is good. Since coffee is good is sitting in the 0th slot, we would have to hack it like this. Not owner, even though we have an owner variable, like that. Okay, that's the point I want to put across. It's that we go into the 0th storage slot and change that, which over here now corresponds to coffee is good. So that gets a little advanced, but it's like, I just wanted to make sure it wasn't like because we called it owner that it happened. It was because we were modifying something that we had put in slot 0, because that's where it sits over here in slot 0. All right, anyway, so that's the hack. So I did that on Polygon. I just quickly deployed this hack contract. Well, I copied the steal contract over into Remix. I then created the hack contract. I'm going to show you. That's how it looked. So I put the hack contract. So you see the steal contract here. I just coded that in here. I in Remix you can specify an existing address that sits on. So we can go to Polyscan. Did I spell that right? Yeah, I think so. And then see this address. Okay. And you see that this was contract creation. So anyway, what I just did there was, this was the contract, this was the steal.sol contract. This is actually living on Polygon. You can see it right here. There's the address. As you can see, the value is 0 because we hacked it. But it started with one matic right down here. And contract creation was yesterday, about 23 hours ago. And you can just take this address right here and put right here, and when you have the interface, so to speak, or even the full implementation like here, you can just say, hey, I have a steal contract. You can either deploy it here, but that doesn't make any sense because then you're deploying it. You need to hack into theirs. So you need to go to address. Notice how it says or. I'm going to move all the way over here so I can be with you. Look at that. It says or add address. So it just means, hey, there's already an address out there that someone else deployed, a steal.sol address, and we're going to connect to that, and that's what this means. So when I click that add address, boom, it just pops up here, and it's now connecting to the actually deployed. It's just very easy to do in Remix. And then we had to go to the hack contract. Look at this. We had to go to the hack contract. We had to deploy the hack contract, and that'll pop up my MetaMask and whatnot, which I don't know. Right now is not showing up, but the point is I had to do that, pay a little bit of Matic to do that, and then call the attack with the address. I would copy the address here into the hack contract and so on. Okay? That's what was happening. That's how it happened. And then, yeah, we're going to leave that. And then the hack happened right here. So this was a transaction. This was from that account to my account. And transfer one Matic. Yeah, that was the hack. Done. you can see that right here. Okay, cool. So that's what happened. Okay, now, next question. How can you become proficient in hacking as well, and why is it important? One, it's super important to know how to hack so that you know how to know the exploits so that you can code better. Okay? The best defense is offense. So if you know how to basically attack, then you know where to put the defense, you know where to be on the lookout. So something just internally sprung out to me and gave me like a feeling when I saw arbitrary address, arbitrary data coming in, and a delegate call. I mean, wow, that's bad. So how can you build these intuitions? How can you get better at hacking and understanding exploits of contracts? Well, I'm glad you asked. I have Ethernaut open. So Ethernaut is a good site to get started. I'm going to show you 3 good resources today. One is Ethernaut. You go to ethernaut.openzeppelin.com. It'll open this page for you. You can also open the console here in the developer. So you go into inspect and you go to console, and it'll look at all this stuff. It'll tell you some stuff, player address, things like that. For this, you're gonna have to be connected to, I forgot what network. Ropsten. You see this current network, Ropsten. Okay, so you're gonna just have to connect to that network. Gonna have to get a little bit of Ropsten ETH. So you just need to find a faucet. So they're describing all that for you, and then you can click play now, and you can see all the various games that are there, levels that are here. The first one being hello, Ethernaut, and it just walks you through what you need to do. And you always just need to say get new instance. And I'm not connected with MetaMask, so it's going to yell at me over here. But you just get a new instance. That just means new instance for that level. It's going to pop up MetaMask for you. You're going to deploy it. It's going to show it deploys. And you just need to do the things they tell you to do here. And then you submit it. Okay, so there's a coin flip. And then typically they'll show you the contract and it'll say, this is a coin flipping game. Well, you need to build up your winning streak by guessing the outcome of a coin flip. To complete this level, you'll need to use your psychic abilities to guess the correct outcome 10 times in a row. So do you need to be David Blaine or someone? No, you do not. Because you can take advantage of the fact that it's these things on the blockchain are pretty predictable, right? Randomness on a blockchain is like extremely difficult to create. There are some ways to do it, like verifiable random functions and so on, but that's another topic. So anyway, so you just need to look through this and see how you can hack it, basically. And yeah, they describe what it means to hack it and whatnot. So you need to say, get new instance, do whatever they say, which is sometimes you can do everything in the console over here. Okay, so you have things like help. I actually don't know if I'm not connected, oh yeah, okay, it does do that. So I can type help and it'll show me player, get the current player address. I can do that. It even shows it down here as well. Ethernaut, that's like the main game contract. Ethernaut, yeah, I think I don't know if I have to do something like that. Oh, that's because I haven't deployed it yet. And then level, okay, the level we know, and and so on, right? And but you can do like send transaction. There are a few things you can do here that you might need for the level. Some levels you can't solve in the console. You need to go over to Remix or something, and you can then basically do what I just did, that address thing, but on the Ropsten network, and then just take the address here from whatever instance address you get. So anyway, that's how you do that. That's Ethernaut. Another good resource for you is to go through the challenges of Capture the Ether. I have another video right here, how to get started with Solidity hacking, Capture the Ether. Go over there, and I'll show you how to get started with those. And it's also a great set of challenges. And then a third resource is Damn Vulnerable DeFi. So this is the offensive security playground for decentralized finance. So this has a bunch of challenges as well. You click it like Unstoppable, and it'll tell you there's a lending pool with 1 million DVT tokens of balance offering flash loans for free. If only there's a way for this attack, or to attack this to stop the pool from offering flash loans. So you can actually go and see the contracts. They're over on GitHub. You can see, this is the actual like lending contract that offers the flash loan. This is whoever receives the flash loan. And then they typically have you, not just typically, they always have you go into this test. So clone this whole thing, damn vulnerable DeFi, to your local computer, and switch the branch to v2.2.0, by the way. And then when you see down here in line 41 through 43, this is where you code your exploit. So this, they deploy the contract for you up here, and then down here in the exploit, don't touch any of the other stuff, don't change it, don't add anything, you don't need to. You just add it right here. And that's where you call certain functions, whatever you need to do to hack it. So you need to figure that out, how to hack it. So I'm going to show you how to hack the first one. To hack the first one, what we're going to realize, so when you actually click complete the challenge, it'll take you to the test thing. We need to see the contracts. Okay, what we need to realize to hack this one is that notice that it relies on an ERC20 token called Damn Valuable Token, DVT. And that's all fine. They import that in interface. During the construction, they're then setting it to whatever token address comes in. Doesn't matter. We can't change that. That's fine. That can be whatever. Then we notice that, okay, they have a function where you can deposit tokens in. So you can actually deposit a certain amount into this contract of these DVT tokens. And what it does is it calls damn valuable token to transfer from whoever called it to this account. So they move DVT token from me to them and by the amount requested. And then the pool balance gets updated by the amount that came in. Okay, fine. Okay, they keep this pool balance. You can deposit tokens in there. Everything is fine. Then we have this flash loan section. And as you can see, it's like basically saying, okay, what's the balance before? They get that. So by the way, this is also how flash loan works. So that's pretty exciting. But anyway, they get the balance before of the tokens that they hold. And then they transfer the token to the sender, depending on how much they want to borrow. So let's say they want to borrow 1,000 tokens or 1,000,000 tokens or something. Great. Send it over to them. If we can afford it, of course. That depends on how many we have. Let's say we have 1,000,000. The user now gets 1,000,000 tokens. That's crazy. But that's what the flash loans are about. And then they make sure that at the end of the day, when the user's done with the 1,000,000 tokens, which by the way, all needs to happen in one block. But when they're done with their flash loan, they send it back to this contract, and the contract is being made whole. All in the same block. Again, all in the same block. Even transaction. So that's pretty crazy. And how do we hack this? So they're kind of telling us that we just need to stop them from offering flash loans. So that kind of gives us a little bit of a hint. One way to do that is we notice this. I'm just going to jump right in. The comments are typically helpful. Insured by the protocol via deposit. Look at that. They're saying, don't worry. The pool balance will always match balance before, because whenever someone deposits a token, we're going to tick up this pool balance. We're going to say pool balance plus equals amount, and we're going to keep track of it like that. What they are missing here is that anybody can just transfer tokens from themselves to this contract. They don't need to call this deposit tokens. Like anybody can just take this damn valuable contract and say transfer from me to them. Okay? So I know they do it right here inside this function, but you don't need to do it inside that function. You can do it outside of that function too. Why is that dangerous? And why does that hack it? Because if we do that, and by the way, we start with 100 tokens is what they say, right? You start with 100 tokens in your balance. If we just move those 100 tokens, or even one, doesn't matter how many, but we're not going to need them. They're not worth anything. So 100 tokens here to this contract without using the deposit tokens. What's going to happen is that the pool balance is going to get out of whack with this like kind of balance of. Okay? Because the pool balance is their own little internal tracker that they're not updating correctly. And the balance of will be the true balance of what they actually have, as is seen from the DVT token. So when we get to this require statement, the balance before is going to be more than not that statement, the line 40 rather. The balance before is going to be more than the pool balance because we moved some stuff over, and the balance before here just asks the DVT token, hey DVT token, how many DVT tokens do I have? Okay, and the pool balance is the internal accounting system. Like there's their internal book here that is not being updated correctly. So I mean, it's like they're putting a door in a building and they're saying we're going to count all the people coming through this door. So anybody calls this deposit tokens like walking through the door. Great, that works. We're going to put them down in a book. That's great. And at the end of the day, we're going to say the amount of people that came in is going to match, the total amount of people in the building, right? If we start at 0, right? Which is fine. That's what they do. So that's fine. The problem is that without them knowing it, this token kind of creates a leaky window or something, that they don't account for. So someone can just crawl through the window separately, or even another door or something that they don't count, that they don't know about. I don't know. That's how to think about it. Okay, so that's how to hack that one. And then you just do that, and you just put that in the test. So what do you put actually in the test over there? Well, you just put a transfer from. So when you go into the test here, right here. So down here, you just put, you have access to the token. You see this .token? You can just do this .token to transfer from yourself to the contract. And that's it. It's fine. Okay. What else? What else do we got? I mean, that's it, really. Yeah, that's it. Cool. So those 3 resources, if you actually spend time and go through them, and whenever you and then there's also a great YouTube channel by Smart Contract Programmer. So go check that out. Okay, I'm gonna pull that out right now. But he has like a great in general, like a fantastic description of Ethereum, but also like and Solidity, but also of how you hack it. Sorry, I should have prepared that, but just give me 1 second. And I'm going to show you his channel here. Okay, so this is his channel. Okay, and he has like some great stuff also on. See, actually, there you go. Damn Vulnerable DeFi has one there. Solidity 0.8. That's a whole playlist. Definitely worth watching. You'll learn everything about Solidity 0.8. And then also Hack Solidity. Look at that. Okay, so he has all these like ways to hack it here. Go through that as well. If you do that and you then do these challenges, and every time you get stuck, you just look it up. You try to. I mean, sit with it. Try to solve it. Try the best you can. Just keep at it. Keep thinking of attack vectors, particularly after you watch his videos and whatnot. You should be good to go. All right. So shout out to Rare Skills. Thank you so much for sending the challenge. That was fun, unexpected, and yeah, good. Subscribe, like this content, comment. What do you like? What didn't you like? I really appreciate you watching. So yeah, hope some of this was helpful to you. That's kind of the best way to really also get started programming Solidity and becoming a smart program engineer. Is that you really like smart contract engineer rather, is that you really like know how to hack these things, that you know where the vulnerabilities are, especially in this day and age. So many hacks are happening. You need to really know what's going on in your code. It's your responsibility. You're handling a lot of funds. Do your best to code it up. I also have a tutorial on how to test your smart contracts. It is not complete, but it gives you a good idea of what to do. I will put together more content on that as well. All right, because it's important to the industry that you take responsibility. We all do, and we really make these contracts unhackable, or as unhackable as can be, right? So good. All right, well, thanks for watching. Take care.